Is it over? Okay, I'll check if possible yesterday. What you have done. So the last problem we have taken f of x is equal to x. Okay, only one problem we have done. Okay, so that's it. Okay, thank you. So now we take one more example. That second example, which is uh, okay, cosine series. I think this is completed. Yeah, I guess. Find the half-range sine series for the function f of x equals pi x minus x square in 0 less than x less than pi. So this is the
Excuse
example.
me, sir.
Yes, please.
Sir, are you recording?
Sorry.
Are you recording?
I'll put
If
that.
not, can you please record? Yes, sir. Thank you so much.
Okay.
Sorry to interrupt.
It's okay. Thank you for the giving information. So I forgot to record. Okay. So now we take this example, that is find the half-range sine series of the function f of x is equal to pi x minus x square in the interval 0 to pi. So find the half-range sine series. So write down this example. Just a minute. Find the half-range sine series of the function f of x equals pi x minus x square in 0 less than x less than pi. So this is another example. So here we need to find a sine series. Okay, so that is half-range sine series. The definition for half-range sine series is we have half-range sine series. So I hope you have remembered that f of x, it contains only sine terms. F of x equals summation n running from 1 to infinity bn sine, so n by x by t. What is equation 1, where bn is 2 by t integration from 0 to t. So please don't confuse with full range and half range. 0 to t, f of x into sine n pi x by t into dx. So this is the definition of half-range series, sine series. So here given information is given, f of x is pi x minus x square and t is pi. So because you have to define a function in the interval 0 less than x less than t. So with this interval we have defining the Fourier series, I mean half-range Fourier series. So in this series, this is 0 less than x less than t. It is defined. Okay, now with that t is pi, f of x is given, and now we need to find bn. So therefore bn is 2 by pi integration from 0 to pi. F of x is pi x minus x square into sine n pi x by pi into dx, n pi x by pi. So pi cancelled. So that is 2 by pi. Now again we have two functions. Left this rule we need to apply. First function into second function. So first function into, that is pi x minus x cube into integration of sine is minus cos nx. So here pi is cancelled. Nx
Sir,
divided by,
x square, no sir.
I'm sorry, x square, correct. Thank you. So this is pi x minus x square into integration of sine is cos nx divided by n minus derivative of pi x minus x square is, derivative of pi x is pi minus derivative of x square is 2x into integration of cos. So we have negative sign minus integration of cos is sin nx divided by n into n square, again plus derivative of pi is 0 and derivative of 2x is 2, so minus 2 into integration of sine is negative, we have negative becomes positive cos nx divided by n cube, and final last term is derivative of 2 is 0. So we stop our by this rules here, limits from 0 to pi. So substitute that limit and evaluate. So just so that is equals 2 by pi. Now when you put an upper limit, pi into pi square minus x, upper limit is pi square into minus cos n pi divided by n, and minus, again I am putting a lower limit, so 0. So when x is 0, this whole thing will be 0, even into cos 0, I can write cos 0. So this is for the first term, whole divided by n, minus, now when you put an upper limit, so I'll take minus outside, so minus outside, when you put an upper limit, pi minus 2x, sorry 2 pi, that is, so x is pi into negative minus sine n pi divided by n square, minus, when you put a lower limit, so this is pi minus 0 into sine 0, so sine 0 is 0 again, so we have minus 2, so minus 2 divided by n cube is, we can take it outside, upper limit is cos n pi minus cos 0. Okay, so that is simplified. So you can look, pi square minus pi square is 0, 0 into cos 0 is 0, sin n pi is 0, sin 0 is 0, and cos 0 is 1, cos n pi value is minus 1 power n. So that becomes 2 divided by pi into, so first term is 0, second term whole term is 0, and for last term gives minus 2 divided by n cube into cos n pi value is minus 1 power n minus 1. So after simplify, this will be, so I can take negative inside, 2 into 2, 4 divided by pi n cube into 1 minus 1 power n. So this is Bn 4 divided by pi n cube into 1 minus, and further when n is even number, so Bn is 0. When n is even, 1 minus 1 is always 0. When n is odd, you will get a plus 2, so that becomes 8 by pi n cube. So that is just observation. So substitute in equation 1. So equation 1 implies that is f of x is pi x minus x square equals summation n running from 1 to infinity Bn, that is 4 divided by pi n cube into 1 minus 1 power n into sin nx. So pi get cancelled. So this is the half range Fourier sine series. Half range sine series for the function pi x minus x square in the interval 0 to pi. Any doubt in this example? So simple integration only. So it's not complicated, I think, if you remember the definition of half range sine series. So let me take one more example. So that is piecewise function. Obtain the Fourier cosine series. Now we need to find a cosine series for the piecewise function x in the interval 0 to pi by 2 and pi minus x in the interval pi by 2 to pi. So take another example. Obtain cosine of range cosine series of the function f of x equals x in the interval 0 less than x less than pi by 2. Sorry, pi minus x in the interval pi by 2 to less than x less than pi. Is that correct? X pi minus x. Okay. So here so this is the endpoint is pi. So that we need to find a Fourier, that is half range cosine series. So the definition is, so that is solution half range cosine series is, the definition of half range cosine series is f of x equals a naught by 2. It contains only cos terms plus summation n running from 1 to infinity an into cos n pi x by t, called as equation 1, where a naught is 2 by t integration from 0 to t f of x into dx, and an is 2 by t integration from 0 to t f of x into cos n pi x by t. Into dx. So given f of x is given, is a piecewise function, and t, in that t is pi. So because this series is defined in the interval 0 less than x less than t. Please note, the series is defined in this interval, so we have to take the endpoint, whatever it is, that is the t. So now with that, so we get we need to find a naught and a n. So a naught will be 2 by t. So therefore a naught is 2 by pi integration from 0 to pi f of x into dx. So since our function f of x is piecewise, so that we need to split the integral, that is 2 by pi integration from 0 to pi by 2 f of x into dx plus 2 by pi integration from pi by 2 to pi f of x into dx, so that the function in the interval 0 to pi by 2 is just x. It is defined as 0 to pi by 2, f of x is defined as x into dx plus 2 by pi. In the interval pi by 2 to pi, the function defined as pi minus x, pi minus x. So that gives, I need to integrate that term, pi minus x into dx. Now after integration, this will be 2 by pi, integration of x is x square by 2, limits from 0 to pi by 2, plus 2 by pi, the now integration of pi is pi x, and integration of x is minus x square by 2, limits from pi by 2 to pi. So now substitute the limit and simplify, we get 2 to cancel, so it is 1 by pi. When you put an upper limit, this is pi square by 4, lower limit gives 0, plus 2 divided by pi. When you put an upper limit, pi square minus pi square by 2 minus lower limit gives pi into pi, pi square by 2 minus, so pi square by 4 divided by 2, so will be pi square by 8. Okay, so this is 1 by 2 into pi by 2 whole square. After simplify, this will be pi by 4 and plus when you multiply with 2 pi, so we get or else we can calculate, this is pi square by 2 minus pi square by 2. So these two terms gives you pi square, so with negative, and we along with this, so I'll write one more line. So 2 by pi square, so pi square by 2 minus pi square is minus pi square, minus into minus plus pi square by 8. So these two terms again cancel 0. So after simplify, pi by 4 plus, so plus sign, that will be pi by 4 again, because 2 by pi into pi square by 8. So pi cancel, 2 ones are 2 fours are. So this will be the final answer, pi by 2. So a naught is pi by 2. So now similarly we need to find an. So that is, therefore an is 2 by pi integration from 0 to pi f of x into cos n pi x by pi, cos n pi x by pi. So that is into dx. So pi cancelled, and this will be, now since we have the function f of x is piecewise, so I can write 2 by pi integration from 0 to pi by 2 f of x into cos nx into dx plus 2 by pi integration from pi by 2 to pi f of x into cos nx dx. Now I need to substitute the function value in the interval 0 to pi by 2 and pi by 2 to pi, and later we need to integrate. So an is 2 by pi integration from 0 to pi by 2, 0 to pi by 2, f of x is x into cos nx into dx, and in the interval plus integral 2 by pi, integration from pi by 2 to pi, f of x is pi minus x into cos nx into dx. Okay, now again we use Leibniz rule, so I can write 2 by pi outside the common, I can take 2 by pi common. So first function x into integration of cos is sin nx divided by n minus derivative of x is 1 into integration of sin is minus cos nx by n square, limits from 0 to pi by 2 plus again 2 by pi, first function that is pi minus x into integration of cos is sin nx divided by n minus derivative of pi minus x is minus 1. So derivative of pi is 0 and derivative of minus x is minus 1 into integration of sin is minus cos nx divided by n square, limits from pi by 2 to pi. So now just apply the limit and simplify. So 2 by pi into, when you put an upper limit, this is pi by 2 into n into sin n pi by 2. So minus into, so again lower limit minus 0, lower limit is 0. So minus into minus plus, when you put an upper limit 1 by n square. So when you put an upper limit, it is cos n pi by 2 minus cos 0, okay, plus 2 by pi into, now when you put an upper limit, pi minus pi, pi minus pi is 0 into sin n pi divided by n. So again minus into, so lower limit, we put a lower limit minus pi minus pi by 2 into sin n pi by 2 divided by n. So next last term, so it is minus into minus plus, plus into minus minus 1 by n square into, when you put an upper limit, it is cos n pi minus cos n pi by 2. So that's it. Now simplify. So here I can take 2 by pi common and just write the simplified form. Okay, that is, here cos 0 is 1 and this whole term is 0. Okay, then here pi minus pi by 2 is pi by 2, the results. Okay, so with that I'll write the next line an, therefore an is 2 by pi, I'll take common factor, and this is pi divided by 2n into sin n pi by 2, and then here plus 1 by n square into cos n pi by 2 minus 1 by n square. So because cos 0 is 1, 1 by n square plus, so this term is 0, so we have negative, so plus 0 minus, so 2, this is minus, we get pi by 2, so that is pi by 2n I can write into sin n pi by 2, and now the last term, so cos n pi is minus 1 power n, so my minus, I just minus into plus is minus 1 power n divided by n square, and then minus into minus plus, plus 1 by n square into cos pi n pi by 2. that is pi n by 2. So here there are some like terms with an opposite sign, that is pi by 2, pi by 2n sin n pi by 2 and minus pi by 2n sin n pi by 2 cancel. Okay, and next we have the like terms cos n pi by 2, cos n pi by 2. So, okay, so then finally we get an as 2 by pi. So here 1 by n square, that is 2 by n square cos n pi by 2 minus 1, so n1 minus 1 by n square I can take common, so that will be the final result is an is 2 by pi into 2 cos n pi by 2 whole divided by, so what was that, whole divided by n square, whole divided by n square minus 1 by n square into 1 plus minus 1 power n. I may, if I am correct, so if I take minus 1 by n square common, so you will get 1 here and then minus 1 power n here. So that is the required an. So that you can multiply, so 2 or can, so this is what the an. So equation 1 implies, so equation 1 implies f of x, so f of x is piecewise function a naught by 2. So what was a naught? A naught is pi by 2. So a naught by 2 is a naught by 2, that is pi by 4, pi by 4 plus summation n running from 1 to infinity an, that is 2 by pi into 2 by n square cos n pi by 2 minus 1 by n square, so n square also we can take outside, into 1 plus minus 1 power n into cos nx is the required for half range cosine series for the given piecewise function. So any doubt? I hope you also simultaneously solving the same problem. Okay. So this is the second example. So we got that is, so further no need to again expanding. So as we know, there are some terms because of cos n pi by 2, if n is any odd number, cos n pi by 2 is 0, and n is any odd number, 1 minus 1. So I'll just, if you see, for n is odd, this term is also 0. So for odd n, odd number, for odd n, so the whole thing itself 0. You can see this whole thing is 0 because here 1 minus 1, 0. For odd n you will get a 0 terms. Only for even n you get a non-zero terms. Okay, so let me take one more example. So again another one is a piecewise function. So that is f of x obtained off range sine series. Now again sine series. F of x is equal to 1 by 4 minus x in the interval 0 to pi 1 by 2 and x minus 3 by 4 in the interval 1 by 2 to 1. So 1 by 4 minus x, I'll write function first. So f of x is, it is 1 by 4 minus x in the interval 0 less than x less than 1 by 2, and then x minus 3 by 4 in the interval 1 by 2 less than x less than 1. Just cross check the function x minus 3 by 4. Okay. So that is the function. So we need to find obtain half range sine series. Half range sine series. Okay. So this now here, as we see in the definition, so the half range sine series is so that is defined as f of x, just we have taken in the first example, summation n running from 1 to infinity bn sine n pi x by t, called as equation 1, where bn is defined as 2 by t integration from 0 to t f of x into sine n pi x by t into dx. Again, this series is defined in the interval 0 less than x less than t. The definition of this series f of x. So now here, given that f of x is given, so it is given f of x is a piecewise function and the value of t is 1. So with that information I can easily obtain bn. Okay, so let me calculate bn. So bn equals 2 by 1 integration from 0 to 1 f of x into sine n pi x by 1 into dx. So now the function f of x defined in the piecewise function, so this will be 2 into integration from 0 to 1 by 2 f of x into sine n pi x dx plus 2 into integration 1 by 2 to 1 by 2 to 1 in f of x into sine n pi x into dx. Okay, so now the function f of x defined in the interval 0 to 1 by 2 is, it was that x 0 to, that is 1 by 2 minus
1 by 4 minus x.
1 by 4 minus x. Okay, and the f of x defined in the interval is x minus 3 by 4. Am I right? I think correct.
Yes, sir.
Yeah, okay, thank you. So now we'll use that given function, so that becomes 2 into integration 0 to 1 by 2. So 1 by 4 minus x into sine n pi x dx plus 2 into integration 1 by 2 to 1 x minus 3 by 4 into sine n pi x dx. So just a simple integration using Leibniz rule, first function. So 2 into first function is 1 by 4 minus x into integration of sine is minus cos n pi x divided by n pi minus derivative of 1 by 4 minus x is minus 1 into minus integration of cos is sine n pi x divided by n pi into n pi gives n pi whole square, limits from 0 to 1 by 2 plus 2 into, again first function is x minus 3 by 4 into integration of sine is minus cos n pi x divided by n pi, again minus derivative of x minus 3 by 4 is 1 into minus integration of cos is sin n pi x divided by n pi into n pi gives n pi whole square, limits from 1 by 2 to 1. So now substitute the limit and simplify. This becomes 2 into, when you put an upper limit, that is of 1 by 4 minus 1 by 2 into minus cos n pi by 2 whole divided by n pi, minus, when you put a lower limit, it is 1 by 4 into minus cos 0 whole divided by n pi. So this is for the first term. Again minus into minus plus, plus into minus minus, I can write 1 by n pi whole square outside. So put a upper limit, it is sin n pi by 2 minus sin 0. Okay, so this is for the first term of integrations. Then plus 2 into, now put a upper limit is 1, so we have minus, I'll write okay, upper limit is 1, so 1 minus 3 by 4 into minus cos n pi divided by n pi, again minus, when you put a lower limit, 1 by 2 minus 3 by 4 into minus cos n pi by 2 minus cos n pi by 2, and in last term it is again minus into minus plus, we have 1 by n pi whole square into sin n pi, when you put an upper limit sin n pi, and when you put a lower limit minus sin n pi by 2. Okay, so this is what after substituting the limits. Be careful. Now you check, is there any terms I can cancel, or is there any terms which become 0. So the value of 1 by 4 minus 1 by 2 is minus 1 by 4, and then cos 0 is 1, and then sin 0 is 0. So cos n pi value, it is minus 1 power n. Again I am sorry, I forgot to simplify. 1 minus 3 by 4 is again plus 1 by 4, and then 1 by 2 minus 3 by 4 is minus 1 by 4, its simplification, and then sin n pi is 0. Okay, so with this will becomes, so what is that? So I can write 2 into, so 2 I can take common, so this is minus 1 by 4, minus 1 by 4 into minus, so we have plus cos n pi by 2 whole divided by 4 n pi. So just take this is 1 by 4 into n pi, 1 by n pi is 1 by 4 n pi. So here it is minus into minus plus, cos 0 is 1 divided by 4 n pi, and then minus, so negative sign, 1 by, so that is sin n pi by 2 divided by n pi whole square. So this is, next is plus into minus, it is cos n pi value is minus 1 power n divided by 4 n pi, and then this is negative minus 1 by 4, so we have minus into minus plus into minus, so it is minus only. So here again this minus, what is that, cos n pi by 2 divided by 4, I miss n pi here, 4 n pi, and then plus, so sin 0 is 0, not plus actually, so here sin 0 is 0, so minus into plus is minus, so minus sin n pi by 2 whole divided by n pi whole square. So again there are some terms can be cancelled like terms, so that is cos n pi by 2 minus cos n pi by 2 divided by 4 n pi, and then these two terms we can add, so that is minus sin n pi by 2, so minus 2 times. So here 1 by 4 n pi, 1 minus 1 by, so I can take 1 by 4 n pi common, so that becomes, so Bn equals 2 into 1 minus of minus 1 power n whole divided by 4 n pi, and then minus is that minus, just cross check, yeah, we have negative sign, so minus 2 divided by n pi whole square into sin n pi by 2. So here is also that when n is even, so sin n pi, you get n is 2n, so sin n pi form we get sin n pi is 0. When n is even, 1 minus 1 is 0. So Bn equal to 0 for even n, again here even n. So that is just a observation. So equation 1 implies, so what is that? F of x equals summation n running from 1 to infinity Bn, that is 2 into 1 minus 1 to the power n divided by 4 n pi minus 2 divided by n pi whole square, 2 divided by n pi whole square into sin n pi by 2 into sin n pi x is the required Fourier of range sine series for the given piecewise function. Okay, so I think you have one more class is waiting. So that's all today's class. Any doubt in these examples? Let me clarify your doubts. Okay, now we'll take this remaining examples. Is there any examples? I think I have completed all the examples. So try to work out exercise practice problems. If you have any doubt in the practice problem, let me know. So next class we'll discuss another concept of Fourier series. Okay, so now attendance just